Hello and welcome to Semaphore Uncut, a podcast for developers about building great products. Today I'm excited to welcome Idit Levine. Idit, thank you so much for joining us.
Hey, thanks so much for having me.
Yeah, great. Idit, please just go ahead and introduce yourself.
So I'm Idit Levine. I'm the founder and the CEO of a small company called Solo.io in Cambridge, Massachusetts in US. Before I started this company, I was working most of my life in a startup company. So I was working in a company called Dynamic Op, who got acquired by VMware. And we were doing cloud before cloud was actually called cloud. Was one of the first engineer there. And then I was moving to another startup company called Cloud Switch, who was actually a very innovative technology back then. We were moving workload from private cloud to public cloud. Again, long time ago before container was even a thing. That got acquired by Verizon, and we built the next generation public cloud of Verizon after it. So I learned quite a lot on cloud and scale. That was really educational for me. And then I joined a company, EMC. Mainly, I really wanted to move to a big company. I was very curious how it will be to work there. And there I was the CTO of Cloud Management Division, which was pretty insane. It was a new division there, and we basically started working on Cloud Foundry and Mesos back then and Kubernetes. So it was pretty innovative and not exactly the regular division that EMC was having back then. And I also was in the CTO office. I was reporting to the global CTO of now Dell EMC. So it was a lot of fun, and we did a lot of open source projects. And one of them specifically became quite a success. It's called Unique, and it was about building a unikernel. So it was kind of like Docker for unikernel. And that became pretty successful. After being in the EMC and the merge with Dell, I basically decided to open my own company. Mainly, my problem was the pace. I'm really working fast. And in EMC, in a big organization, usually you're being slowed down by other stuff. So I started solo almost 3 years ago. And to be honest, we're having so much fun.
Great. Yeah. Those smaller environments tend to create more fun.
Yeah.
Hey everyone. Semaphore has published an open source book called CI/CD with Docker and Kubernetes. It combines just the right amount of best practices and practical advice for shipping cloud-native apps. Download your free copy today at semaphoreCI.com. Okay, and you have a very interesting line of products and how you got there. Some of our listeners probably heard about Gloo, and that's something that maybe majority is familiar what it is. But nevertheless, can you share a bit more about your products and the technical side behind those products?
For sure. So let me explain you first what was my thinking when I was starting Solo, and that will drive the understanding of why we have the product that we're having. So I started Solo 3 years ago, so almost 3 years ago. And when I started it, it was clear to me that, there was a huge shift in the market, right? Everybody was moving from monolithic to microservices. And as one, when there is big shift like this, there is a lot of vacuum and there is a lot of technology and a lot of need in the market for new technology and tools. So what I realized is that a lot of people focusing about how to rewrite their application, which is a big problem with, I'm not arguing that it's a big problem. I'm just arguing that that's where stuff is starting. And what I was more passionate about is I said, once someone is actually going to rewrite this application, it will need to deploy it somewhere. Okay, so let's say that Kubernetes has solved that problem. But what's interesting is that now everything is distributed. And when everything is distributed, everything have to go on the wire. And if everything have to go in the wire, I personally believe that networking will become the queen of the infrastructure. I believe that there's so much we will be able to do with this. So, stuff like how do you make sure that two microservices will be able to commute to each other? How do you make sure that they're going to do it in a safe way? And how do you make sure that you understand what's going on now when your logs is spread all over around and there is latency between your microservices? How do you deal with this? So when I looked around, I discovered that service mesh is something that just was pretty emerged by the guy from Buoyant, and then STO was launched by Google and IBM. And I basically look at this and I said, this is the future. And I really want to take part of it. But here's what else I realized. I realized that as a startup, I'm not Google and I'm not IBM. I cannot bet on technology that will come to the market only in 3 years or will be everywhere in 3 years. And just said, okay, until then, I will live with money that the investor gave me. It's just never working like this. So, but I tried to understand and I said, okay, so I know where I want to go, but I know it will take to the market to get there between 2 to 3 years. What is these things that will be very important that I can build right now? But I know that it will give me a huge advantage when service mesh will be everywhere because my team will be ready. It will make my team very attractive. And what I came with is that this is Envoy. So Envoy proxy was by far the new generation proxy. The technology there was a little bit different than what was in the market before that. It was API driven. You will be able to extend it quite dramatically. You don't need to do a hot restarts every time that you load in configuration. There's the discovery function. There's so much good there that I thought this will be huge. This will be what drives service mesh. So what if I will take this and try to apply it to what people will buy today? And when I look at what people will buy today, what I came with is that API gateway is something that people already buy. And it's a 10 years technology, right? It's nothing new. But because it's a 10 years technology, if you look at products that are in the market there, like Apogee or Kong, you will discover that basically they're not built ready to the cloud and the microservices and the amount of API that's running and API calls right now in terms of scale. So I basically said to myself, those companies claiming that they are the microservices API gateway, but they themselves is not microservices, right? Build as microservices. Their state need to be saved in something like Cassandra, active, that the user need to manage. The proxies need to be auto restart every time that you load in the configuration. It's going to be extremely hard in that dynamic environment. And specifically, no discovery and a lot of other stuff. It's not a declarative model like we are used to it today. So I basically said to myself, what if I will take this Envoy proxy, which I believe will be the future of the cloud, and I'm going to build the best API gateway, like the way people will build an API gateway today, not 10 years ago. And that's where our Gloo basically come to life. So we built Gloo, as I said. Gloo is everything that I described, declarative model based on top of Envoy, very extensible, very, very pluggable. And that was one of the things that I realized back on the future, because Envoy has this ability to be extended. It's very important that Gloo will be able to do this, because I believe that Envoy will be a big community. So I wanted to leverage this community quick. Also, you don't need a cluster, active Cassandra cluster. You can basically, from the get-go, it's reading in Go, and it's basically using the CRD of Kubernetes as the state. So you don't need to back it up and so on. If you already have Kubernetes, whatever you're doing with this, that's good. You don't need to worry about Gloo at that point. So we built Gloo. We open sourced it quite a long time ago, I think like a year and a half ago or so. We learn a lot from this process, mainly working with customers. So today, kind of like, we're basically running in huge organizations, like big, big, big ones. And that's very, very useful for us. Companies like Vonage, like ADP, like Carfax, big, big organization, a lot of banks, telecommunication companies. So it's really, really useful for us because each of them has their own infrastructure and it's different. And the beautiful of it is that all of them eventually want to go to service mesh, which means that Gloo is a very good stepping stone to where they want to go, because Envoy is not that simple to run in production. So that's where we kind of like started. And as I said to you, Gloo right now is in explosion mode. We are getting so many customers, and, the Corona didn't slow us down. Actually, we are just going faster right now. So it's kind of like really impressive. And of course, we are contributing Envoy upstream for a lot of, 2 years now. Really, really know Envoy in and out. That's helped us a lot because, as I said, that is the piece that has become very important in service mesh ecosystem. So that's where we started. But we always wanted to go to service mesh. And I really wanted to go to service mesh, but I also knew that I didn't want to build a service mesh. And the reason is because I predicted that would be a very crowded ecosystem. And the reason is because when I started, there was already Buoyant with Linkerd and STO. And I thought that they're going to be more technology, mainly based because I looked at the STO code back then. It wasn't that good. And Linkerd, when we look at it first, it was still like a Java kind of like style, right? So it definitely wasn't that good. So I believe that there will become more companies to compete. And I was really right, because very soon after, HashiCorp reached out to us. I'm a very good friend with Mitchell and Armon, and they basically asked me, look, here's the thing. We're going to compete with STO. We wanted to basically build Console Connect. But here's the thing, people will be able to come and plug in whatever proxy they want.
Mm-hmm.
And we will build this very simple Go proxy, but we want out of the box to support Envoy. And we know you know Envoy very well. What if we will work on this together? So we basically launched together the first version of Console Connect. And that's where I kind of like understood that I don't want to build service mesh, but I do believe that there are going to be a lot of option out there. And I didn't want to compete on this ecosystem. So I tried to figure out what will be the next problem that everybody will have in the market once service mesh will become everywhere. And what I came with is that they're going to be more than one. And what do you mean there will be more than one? There are going to be more than one instance of the mesh. So it could be the same type. Like, for instance, you have 2 clusters of Kubernetes and you will put STO on each of them. You already have to. Definitely if you have testing and staging. So that's where I started. But then I said, but what will happen if someone will run Console Connect on-prem, but we want to go to Google Cloud? Google Cloud is STO. They probably want to leverage that. How is that going to work? And that's where it's hit me that it's not only that we're going to have more than one instance of service mesh, there could be chance that it will be a different one. So basically, that's when I came with a project called back then Super Gloo, and now we're calling it Service Mesh Hub, that basically the vision did not change it for almost 2 years, right? And the idea was we need somehow to make those meshes to work together. So what I did is that, first of all, we need to make sure that they're communicating the same language. And again, it was a prediction of mine that they're going to be a lot. And, 2 weeks after we announced this project, AppMesh was announced in AWS. And fast forward today, Microsoft is we're helping them building their own service mesh. So if you're looking at the whole kind of like ecosystem, it means that the 3 big cloud will have different service meshes. So when I tried to figure out how to solve this problem, I came with 2 solutions. The first one, we need, first of all, to make sure that all those meshes will talk the same language, right? We need an abstraction layer. And by the way, we need a simple one because right now, back then at least, STO was, and still, very complex API. If you're looking at the API of STO, you see stuff there like sidecar. Why do I need to know about sidecar? This is implementation details, right? What I do want to know is about what is the functionality that I'm getting from it, a retry or the circuit breaking. This is the stuff that I really care about. Mm-hmm. So we came with a very simple API that trying to explain how service mesh is really working, what it's actually doing. And it's very simple. You're creating a source, group of source, you're creating a group of destination, and you're putting a configuration on the wire, right? This is my source. This is my destination. I don't want them to talk. This is my source. This is my destination. I want them to talk only if the user is in it. This is my source. This is my destination. I want to do a retry of 5, right? But this is basically how it's working. So if you try to simplify mesh, this is how you should treat it. So that will solve a lot of the problem. First of all, simple API. Customer does not need to know which mesh he's talking to. He doesn't really care if he doesn't want to. And it's also not locking him to one. Because let's say that you bet on Linkerd, but now Linkerd will STO become the winner. Mm-hmm. Just switch, right? It's not a problem. The implementation it's not going to change the API. And that's very important because we've been there before. We saw, all the orchestration fight before that about, Mesos and Kubernetes and Cloud Foundry and Docker Swarm. And whoever not choose Kubernetes back then needed to throw everything to the garbage. So this layer is protecting you, which is really important. The second thing that we did is we said, okay, so now I have, let's say, AppMesh and STO on-prem. How is that going to work together? So we came with the concept of grouping. So we're calling it virtual mesh. You can group 2 or 3 or as much as mesh as you want as one and treat it as one virtual mesh. And now you can basically, make one service in one class and talk to the other one seamlessly because we are taking care of all the work behind the scene, the orchestration of, the root certificate and all the problem that you need to basically be getting in. So again, first we're protecting you have one language, below that we're grouping it. And on top of it, now we can do strange stuff like a failover or routing based off localization and so on. So this is the stuff that's coming on top of it. And this is what Service Mesh Hub. So again, Gloo, starting helping you with what called north-south entry to your clusters or to your data center. Service Mesh Hub, helping you adopt Service Mesh east-west. And then the last thing that we did is we basically understood that when we have customer running those, they just obstruct the network. And I don't know any customer that I have that just took Gloo out of the box or Service Mesh Hub and said, I'm good to go. I don't need you guys. Always they want to customize. So when you need to customize service mesh or Glue. It's a complex problem. There's the data plane and the control plane, and you need to be able to customize both of them. What we came with together with Google and the community is the fact that we can help extend Envoy pretty easily with something called WebAssembly, with technology called WebAssembly, which I personally think that is the future of the cloud. So we built something called WebAssembly Hub to give the Docker-like experience to be able to extend your meshes and API gateway.
Yeah, lay it all together. And yeah, you laid it out nicely. Yeah, great. Hey, I'm going to take a quick break here and tell you that Semaphore has a new book out called CI/CD with Docker and Kubernetes. If you are looking to deploy cloud-native apps, it's going to show you the most productive way of doing that. And the best of all, it's free. Download your free copy today at semaphoreCI.com. And talking about Envoy, I mentioned in the prep call that we had Matt Klein, creator of Envoy, on the podcast. And I remember giving him maybe a bit of a hard time with C++, which is the implementation of the Envoy, because we discussed that Envoy is pluggable on multiple layers, and then it's great. However, you have to write some C++. And during the university, C++ was my kind of the default language, and it is a sharp tool. And things are getting a bit nicer for developers. So yeah, maybe I don't have to worry that much about memory safety and all those things.
Yeah.
And you already said that you see WebAssembly as a huge thing that will be around for a while and be an important player. Can you, for our listeners, give us a background on WebAssembly? Why do you think it's so great? And how in practice do you create those plugins and plug them into the Envoy?
Yeah. For sure. So let's maybe highlight about the Envoy architecture that you will understand how it's working today and why it was very important to us to bring it there. So today with Envoy, and again, this is what makes Envoy so well, is the fact that there is the concept of filter chain. Envoy is a proxy. That's what's called the data plane. When a request is coming to the data center, it's only going to the data plane. It's not going, Gloo is not involved, for instance, at all. But before that, someone needs to configure Envoy. And that's what Gloo responsibility is. So Gloo, as a control plane, is looking at all your environment, is always watching it, right? If something go down, it's telling Envoy. Same thing with the set, right? The secret. If there is any rotation of the secret, Luke is watching it, say, oh, change record. It's taking it and making sure to give it to Envoy. So basically, he's watching every time that something changes, is creating the configuration of Envoy and serve it on the XDS. So now, in the request path, as I said, all of this happening offline, right? It's like not on the runtime. Then when a request is coming to Envoy, it's going to Envoy only, and it's going to the chain of filter. So this is basically an ability to decide and customize what do you want to do when the request will come. So there is some filters that you usually do, like, right, it just makes sense to do this. But there is some other stuff because every customer wants something else in a different order, in a different, security skills and so on. So the beauty of what Klein did, which is, I think, brilliant, is the fact that you can actually write whatever filters you want, as you say, in C++. Actually, it's even more complex. It's C++ async, which is like nightmare. But you can basically write your own, and then the only thing that you need to do is basically recompile Envoy. Now, what does it mean? So to write C++ async, it's very hard, specifically because a lot of the libraries not exist. If I want right now to write a filter to communicate with Kafka, it's hard because the library itself does not exist. So I need to rewrite every library, which is really, really hard and consuming a lot of time. The second thing is that not a lot of people know fluent in C++. It's hard language to use. And the last one is that the compilation of Envoy itself, I can tell you that every person that joined my company on the beginning took him at least 2 weeks to figure out how to compile Envoy. And I'm talking about very bright people. It's just hard. Bazel is the tool that we are using too. It's way better than it was 2 years ago, but it's still a hard problem to do. So to be honest, we took a decision, not like STO. STO, what they said, look, this is too hard. We do want people to be able to write their own logic. What are we going to do? We're going to use Mixer, if you remember. Every time that the request is coming to Envoy, it will send it to a gRPC for a Go, basically a service. And then you can plug into the Go, whatever you want in Go, and then it's running. Now, that's what costs STO all the problem with performance, because every time that you want to do something, you need to do a round trip. And it just was very, very intensive in terms of performance. We did a different approach. We said, no, this is a request, but we have to be extremely fast there. We can't take a round trip. Though we will do the hard work because we can't expect our customer to write their own logic. So they will tell us what they want, and we will write those filters and build into Envoy. All the community understand that it's hard. There's not a lot of people who are capable of writing Envoy filter. So we've thought together with all the community of what can we do in order to solve this problem. And then Google came with a very good solution, which is WebAssembly. So what does it mean? So WebAssembly, it's actually a technology that wasn't built for Envoy. It was built specifically for a browser. And WebAssembly, it's actually funny enough, it's not only for the web and it's not assembly, it's instruction code, but it's fine. But the idea with what's special about it is that they had to have some functionality to this WASM filter or the WASM models that was very important. First of all, if you want to run it in the browser, the reason they even want it is because they want something faster than JavaScript. JavaScript is usually, is very high level, so it's taking time to perform. If you want a very good performance, you want to run something very fast, they thought that would be a good solution. They also knew that it should be extremely safe. So what they did, they basically put it in a sandbox because you don't want a website to be able to take the browser down, right? So you need to protect that. So they put it in a sandbox. The other thing that is very important is that it's very important that it will run everywhere because browser running everywhere. So you need it on a phone, you need it on a mainframe, you need it everywhere. It's really important that you will be able to run it in every platform. And the last one, it will be very useful if also you will be able to run it in any language because as you said, C++ is relatively hard. What if we can write it in Rust? What if we can run it in an assembly script, right? That would be way simple for people. And then, so the performance, the security piece, the fact that you can run it on everywhere, like the mobility, as well as the language. So that's basically where it's coming from. Now, this technology is very interesting. And now they basically created something called WASI, which is basically an interface that allows you to take it from the web and bring it to different places. So Google thought it would be a very good idea to basically put it in Envoy. So what we did, we wrote a filter. They basically wrote a filter that basically know how to talk to a WASM model. We brought WASM to the memory of Envoy. We basically created an ABI, it's called an interface, right? Like API, but for binary, that will know how to communicate between them. And now basically what we can do is write a WASM model and bring it to Envoy. And then Envoy extend. Now you don't need to recompile because it's getting on top of. So you don't need to recompile Envoy. You can use whatever language you want. It's safe, it's fast. That's not bad, right? That's exactly the stuff that we need. So this is what Google did, and we helped them a bit, but they did most of the work. And when I saw this, I said, this is really, really important. But here's the thing. It's still not simple. You still need to build this WASM, which is not a simple thing. Then you need to bring in somehow to Envoy memory, which is again not a simple thing. Then you need to still write configuration for the WASM filter and Envoy. That's a lot of stuff that again, it's not intuitive. So what I saw when I look at it, I said to myself, okay, we need to keep it way simpler. We need to simplify for our user. I saw a huge similarity to what Docker did. So if you think about it, Docker did not the one who invented Linux container. Actually, it was Google again. But what Docker knew how to do it very well is to take something very complex and make it easy to work. And this is basically what we tried to do to WASM. So we said, at some point, it's the same thing. Google was the one who brought it to Envoy. But we felt that we can give him the Docker-like experience. So we built a tool called WASMI. And basically, it's very simple. When you're running WASMI in it, it's creating you a library and container, download everything. There's no dependency besides Docker. And then basically, it's giving you already the library with the structure of what you should build. And then you're opening it, you're adding some business logic. And then when you finish writing the business logic, you can build it in one command line, WASMI build. You can push it to a registry that we created called WebAssembly Hub. You can pull it from there if you want to play with it or test it on local Envoy. And we added another command called deploy. And then you can deploy it. We did it in the beginning with Gloo. And what happened is that Google really liked it. They saw this and said, wow, this is really good. That's the experience that we want for our customers. What if we will announce it again also as the official way to extend STL? So that's what we did together, and we announced it together. And now basically WebAssembly is the only way to extend Gloo and STL and I believe other platform in the future. So that's really, really powerful. And I'm really excited about the future of it. And I think it should go to other places. It shouldn't only be on Envoy. I think it will be extend a lot more stuff on the cloud. And we already see people doing it for OPA, Open Policy Agent, NATS, the SAP app. So there is more people to understand that this concept is extremely important.
Yeah, that all sounds great. And it's also something, if we take an analogy that worked in the past also. So I remember some various software which was written in C++ was easily extendable by some Python scripts or some Lua scripts. We saw it in Nginx and a number of other places. But this is completely different technology stack and for a different time. So as we talked, it is something that could be around for many years to come.
Yeah, I believe we are just starting. As I said, I think that this technology will change the world of cloud. It's funny, but I think a year ago, Solomon Hayek, the founder of Docker, tweeted about it. And he said that if Wasm and Wazi was around when he was starting Docker, he will never needed to build Docker. We'll just use this one. So I believe that there is the same importance to what Wasm is doing right now to what Docker did back then. So I really believe it will be a huge refresh in the market around it. So yeah, try it out. You just go to WebAssemblyHub.io, and we are also on Slack, so you can come ask us any question that you want. But as I said, I'm very excited about this specifically.
Great. Yeah, and it's questionable in terms of timing. Is it good that it wasn't around when Solomon was creating Docker or not?
Yeah, that's a good question.
Yeah, we'll leave it open.
Yeah, exactly.
Well, thank you. It was an amazing conversation. We went really deep, but I think it's very digestible and easy to follow. And yeah, good luck with all the projects and pushing the whole community forward.
Thanks so much. Yeah, and come check it out in Solo.io, and we are hiring and growing like crazy, and join our Slack community. We would love to have you guys.
Sure. Thank you. And we'll be sure to add additional links to WebAssembly.io and Solo.io in the notes.
Fantastic.
Thank you so much. Have a great day.
Thank you. Bye-bye. Thank you for having me.